if we've got a function of x and we want to differentiate that with respect to x, well, we know how to do this. If we got x squared, we know d dx of x squared is equal to 2x. We have rules, right? So, but the problem is, when we're differentiating implicitly, say we have xy or xy plus x plus y, we have to, we want to differentiate this with respect to x if we're looking to find dy by dx. But our issue here is that how do we differentiate y with respect to x? Well, we'll have a look at that now. Or any function of y, just pick y here. So if we have a function of y, we want to differentiate it with respect to x, as we said. But we actually don't know we know how to differentiate this with respect to y, because all we do is it's equivalent to differentiating a function of x with respect to x, because it's the same variable here. And then what we do is, a little workaround is we multiply by dy by dx. You see, you get this almost cancellation effect, and you get d dx of f of y, which is what you want. So that's our rule. So this y term here, this differentiate, if we differentiate that with respect to y, it differentiates to 1, then we multiply by dy dx. Alright, and if we had y squared, we get 2y. So d dx. Hopefully you can get your head around this. It's not a cancellation. It's the chain rule. Remember when if you want to find dy by dx, that's equal to dy by du by du by dx. So if you remember this chain rule, and then when you're implicitly differentiating something, it's a function of multiple variables, just two variables for this chain rule, but as you get up into higher dimensions, there's more and more different versions of this chain rule that you can learn and remember. It's a pretty simple thing to do once you get your head around it. Just sometimes the idea of this chain rule can be a little bit weird, especially if you've only just been introduced to like differentiation and calculus and that. But if you go through a few examples, and we'll go through one in this video, and you keep practicing, then you'll definitely get there in the end. So now on to these. So for this example, we're going to try find dy by dx, and the way we're going to do that is differentiate implicitly, as explained before. So this first bit, we have the product rule. So we take each term independently, we keep one constant and differentiate the other, then we keep the one we differentiate first constant, differentiate that, and then add these together. So first I'm going to keep this y squared as it is and just differentiate the x. So that gives me y squared, and now I've got to add this to y squared differentiated with respect to x. So that gives me 2y dy by dx, but we've also got this x, so 2y x dy by dx. And then we're going to subtract 3, that one's pretty simple. And then we want to add 2 dy by dx, and that's equal to 0 still. So to find dy by dx, pretty simple. We're going to factorise out dy by dx. To get 2yx plus 2, and then from both sides we're going to subtract minus 3 and y squared, so 3 minus y squared, and then dy by dx by divided through by all this is equal to minus over, and we'll factorise out the 2 just for neatness, xy plus 1, and that's our answer in this example. So as you can see, always remember, if you're differentiating this y with respect to x, to put your dy dx here. Remember to use the product rule as well. Something people can just forget, and try to be able to do this product rule in your head. If you don't want to be having to write down u equal to x, v equal to y squared, etc. Because it just can take too long to do these problems. You want to be able to do them quickly. So I hope you enjoyed this video. Please like and subscribe, and I'll see you in the next one.